Bismillahirrahmanirrahim. Okay, guys, I have to tell you how to sketch the graphs of um, the trigonometric functions. So, in our first session, we'll learn how to draw the graph of y equal to sine x or y equal to cos x. Okay, we shall be starting from y equal to sine x. Then we'll take this on to uh, y equal to a sine x, okay, and then we'll talk about y is equal to a sine x plus b, and then we'll take it to y is equal to a sine bx plus c. Okay, so we'll start from the simplest form and then we'll take it up to this level. Okay, and all of these things will be happening with the cos x with as well. Uh, Whatever I'll be telling you about the sin x, that will apply to the cos x with a very minor small change. Okay, so now let's start with the y equal to sine x. Okay. Now, the thing is, some of the students have been seeing that whenever they have to sketch the graph of these trigonometric functions, they think that they have to use a calculator. Yes, you can use a calculator to confirm some of the values of sine x, but if you remember this circle thing that your uh, like remember that now I will tell you the things about this y equal to sine x. Okay, so if you have y equal to sine x, so you must know that your sine is 0 here, it is 1 here, it is 0 here, and then this is going to be minus 1 here. Okay, so when you have to sketch the graph of y equal to sine x, the first thing that you must remember is that you will be taking the intervals of 90 degrees over here. Okay, and if you're dealing in radians, you will be taking them in terms of pi by 2, pi, 3 pi by 2, and then 2 pi. Okay, so we are starting this to sketch this from 0 to 360 degrees. Okay, here it is 1, and here it is going to be minus 1. Okay, so now look at this. When you have sine 0, it is going to be 0 here. Then at 90, it is going to be 1. At 180, it is going to be again 0. And when it is 270, it is going to be minus 1. And then at 360, it is again going to be 0. So just remember the flow of this curve like this, okay, to draw it like this. So this is the graph for y equal to sine x. Okay. If I continue sketching this curve will keep on going like this. So this is called the sine wave. If I go backwards, so this will be going backwards like this. Okay, so this is your y equal to sine x. Now with this, I'll be telling you how to sketch the graph of y is equal to cos x. Now see, when it is y equal to cos x, so you see your cos x is it is something like cos is 1 because cos 0 is 1. Okay, here your cos is 0, then it is minus 1 here, and then this is going to be 0 again here. Okay, so when I draw this on the same axis, the graph for the y is equal to cos x, you will see that we have, like, this is going to start from here, then this goes up to this, then it comes here, and then this, and then this. And if I continue it like this, so the graph of y is equal to cos x is going to be like this. it has exactly the same shape, but you see that there is the difference between there is only the difference of the starting value over here. The sine remains between 1 and minus 1. Cos also remains between 1 and minus 1. Okay, so that is how you have the graphs of the sine x and the cos x behaving in the same way. Okay, when we draw the graph of y is equal to sine x, okay, we like draw it like this, like when it is 0, it is at 0. Okay, so instead of 0, let me give you some terms that will help you to remember them and to draw them quickly. Okay, now um, again the intervals are of 90 degrees. Okay, and okay, now when you're drawing the graph of this sine x, you see that this is the maximum value over here, because sine x do not go beyond y 1. Okay, and it does not go below this minus 1 over here. Okay, so this is the maximum point on this curve here. Okay, and this one is going to be the minimum point, and again this is the maximum point here. Okay, and this is the minimum point over here. So when you're drawing the graph of the sine x, so you have to talk to yourself like this. Okay, you would be saying, okay, this is going to be now other than this maximum and minimum, you have to look at this line as well. This line over here, this line is known as the axis of the curve. Okay, this is called the axis of the curve, because the curve is moving about this axis over here. Okay, so look at this, how you will be talking to yourself while drawing this sketch. Okay, you would say, okay, it's sine x, so axis maximum, axis minimum, axis, and if you were to go beyond this, this is going to be maximum, axis, minimum, and so on. Okay, so here is a sketch for this y is equal to sine x. Okay, you try to draw it smoothly because I have very slippery surface here. So if it was your cos, now remember, sine x is going to start from the axis. So this is axis, you must note it down. Axis, maximum, axis, minimum, axis, maximum, axis, and so on. Okay, and imagine for the cos x, when you have y is equal to cos x. So the cos graph starts from, yeah, would someone tell us if this green one is the graph of the cos x? So the cos graph starts from the axis. Okay, it starts from the axis, goes down to the minimum here. Okay, and then this one is again here it is at axis, then this is going to be at the maximum, axis, and then minimum. Okay, so the cos x graph starts from the maximum point. Okay, maximum, then goes down to the axis, then goes to the minimum, further down to minimum, then starts rising to the axis, goes to the maximum, starts coming downwards, axis, minimum, axis, and so on. So remember this flow. You can take the screenshot over here so that you can remember how does this graph behave. Okay, so I have told you about this y is equal to sine x and cos x, the very basic graphs over here. Okay, now I'll be telling you about the before this a sine x, I'll be telling you about this let's do this y equal to a sine x. Okay, I have to move to the next slide. Now y equal to a sine x, y equal to a sine x. Okay, now when we draw this y equal to a sine x, you have to look at this circle first of all. Okay, Now this is your 0, 1, 0, and then minus 1. Okay. Now this is y equal to sine x. Now suppose if you have uh, to have these values for y is equal to 2 sine x. Hmm? So that would mean you will be multiplying all these values by 2. So this is going to be 0 here, this is going to be 2 here, this is going to be 0 here, this is going to be minus 2 here. Okay. Now suppose if you want to draw this for y is equal to uh, 3 sine x. Okay, this is y is equal to 3 sine x. So this is 0, this is 3, this is 0, and this one is minus 3. Now, what is happening to the graph over here? You just see, uh, now you have 1 here, this is minus 1 here. You have 2 here, this is minus 2 here. You have 3 here, and you have minus 3 here. Okay. You can draw for some other numbers as well. So this is your 90, this is your 180, this is your 270, and this one is your 360. Okay. Now, first of all, for the sine x, I'm using the black line for the sine, okay? So x is maximum, x is minimum, x is. So here is the graph for this y is equal to sine x, okay? Let's use a red line for this y is equal to sine x. So now this is the x's, the maximum, the x's, the minimum, the x's. Okay, so this curve is going to be like this. Okay, now let's use the green color for this y is equal to 3 sine x. So x's, maximum, x's, and minimum, and then this is going to be x's. Okay, so this is going to be like this and then like this. Okay, so this coefficient of the sine x or the cos x, this is basically called the amplitude of this curve over here. Okay, this is the amplitude or amplitude, whatever you want to call it. Okay, this is the amplitude of the curve. Okay, amplitude is basically the distance of the curve, the distance of the turning point of the maximum or the minimum point from the axis of the curve. Okay, so this much is the amplitude in this case of this sine x. Okay, when you have y is equal to um, 2 sine x. So this much is the amplitude over here, okay? And then when you have, so this is the 2 over, you can see that the distance is 2 from the axis to the maximum point over here, okay? And when you are going to draw this for, let's say, y equal to 3 sine x, so this is going to be the amplitude, which is going to be this 3 over here, okay? So uh, the rule is the same, that is going to be x's and then maximum and then x's and then minimum and then x's and so on. But when it is when you move from y equal to sine x to y equal to 2 sine x, the maximum value becomes 2 and the minimum value becomes minus 1. Okay, so remember, suppose you have to draw the graph of y equal to, let's say you have to draw the graph of y is equal to 2 sine x, okay? So there is no need of calculator, you see, okay? This is my 0, 90, 180, 270, and then this is going to be 360. So here is the axis of the curve, okay? And then this is your 2, and this is going to be your minus 2, because your amplitude is 2 over here. So axis, maximum, axis, minimum, axis. So here is the sketch for y is equal to 2 sine x, okay? And suppose if you have to draw the graph of y is equal to, let's say, 3 cos x. So this would be, again, you will always be having the intervals of 90 degrees for sine and cos. Says 180, this is 270, and this one is 360. So I have 3 here. I can write minus 3 here. So this cost starts from the maximum, okay? So maximum x's, minimum x's, and the maximum. So here is going to be the graph of this. You try to draw it a beautiful curve like this, okay? So this is your y is equal to 3 cos x. Sometimes you can have y equal to, for example, minus 2 sine x, okay? You can have y equal to minus 2 sine x. So remember when you had the line y equal to x is like this. So if it is y, this is your y equal to x. And when it is y equal to minus x, the same line is going to go downwards. This is y is equal to minus x. Remember when you had y is equal to x squared. So the graph is going to be like this. This is your y equal to x squared. And what if when you have y is equal to minus x squared? This is going to be a curve like this, okay? If you have, if this one is the minimum point here for y equal to x squared, the same point becomes a maximum point when it is going to be y equal to minus x squared. So because of the minus amplitude over here, we can't say the amplitude is minus. Amplitude is always, because this is simply a magnitude, okay? So if you have a minus coefficient with this sine x or the cos x, you have to, like, for example, if this is your, this red one is a graph of y is equal to 2 sine x. So for y is equal to minus 2 sine x, you will have, like at 90, if you have the maximum point, for minus 2 sine x at 90, you will have the minimum point. And this minimum point will be now maximum point. So you will revert the graph. So this graph would look like this. So the green one is a graph for y is equal to minus 2 sine x. And suppose if you were drawing this y is equal to minus 3 cos x, okay? Bacho, for minus 3 cos x. So this maximum point is now going to be the minimum point. This minimum point will now be the maximum point. And this maximum will be now the minimum point. I hope you understand this. Yeah? Kyun, bacho? I want to hear from you. You haven't spoken for so long. It's only me talking for so much time. So is it clear that why this curve is going to be reverted when you have the minus coefficient with the sine or the cos? Is it clear? I have to move now, bacho. Say yes
Yes,
or
sir.
no. Okay. So
Yes, sir.
yeah. So now I'm just going to add more spices into this this sketch. So we started from y equal to sine x. Then we have so far moved on to y equal to a sine x. Okay. Now I'm going to go to the next stage where it is y is equal to a sine x plus b. Okay. Now look at this y equal to sine x. If it is y equal to sine x, these critical values over here are going to be 0, 1, 0, and minus 1. Okay. And the graph looks like this. This is 1 here and this is minus 1 here. Okay. Now what if we have, instead of this, we have like instead of this y is equal to sine x, this is y is equal to sine x plus 1. Okay. So this means that all the values of y are now going to be increased by 1. So you will have 1 here, you will have 2 here, you will have 1 here, and you will have 0 over here, because we have added 1 into all these, values of y. Okay. And now this graph would be like this. This is your 0, 90, 180, 270, and this is your 360. Now we'll be drawing a dotted line here, okay? This dotted line is called the axis of the curve, okay? Now the axis, you can see that the axis was right here initially when it was just sine x, okay? This is the axis over here. And now the axis has been translated. Remember the translation you have studied in your O levels, okay? Now this has moved up. It has gone from 0 to 1, okay? So this is basically where you have the this over here shows the axis for the y equal to sine x. Now the um, axis is going to be y equal to 1. You see that from this 0, this is the maximum 1 here, and this is the minimum. There is a gap of 1 and 1 over here. And it's the same here. It is 1, and this is going to be 1 over here, okay? So now the maximum value is 2 and the minimum value is 0. So we maintain the same thing, that this is x's maximum, x's minimum, x's, okay? So this graph is going to be like this, okay? So it was here, okay? So this is the graph for y is equal to sine x plus 1. Suppose you have to draw the graph for y is equal to cos x plus 2, okay? So then you will say, okay, I have to draw the graph of y is equal to cos x plus 2. So this is 0, 90, 180, 270, and then there is the 360, okay? So now you will have the axis of the graph at this 2, okay? So here is the axis of this graph, okay? And this 3 is the maximum and this 1 is the minimum, okay? So the graph of cos goes like this. This is going to be maximum axis, minimum axis, and you have maximum here, okay? So the graph is going to be like this now. Okay, so this is the graph of y is equal to cos x plus 2. Now I'm going to combine both this a. I'm going to tell you about this now. If it is y is equal to a sine x plus b, then this b is, sorry, this a is the amplitude, okay? You keep on taking these screenshots, okay? And this B is going to be the axis of the curve. This is the axis of the curve, okay? Now, suppose we have to draw y equal to 2.
सर आप पिछली स्लाइड पे एक सेकंड जा सकते हैं सॉरी
Okay, 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 okay. Yes. Hmm? Okay, I'm moving now, okay?
यस सर थैंक यू
Okay. Now suppose you draw the graph of y is equal to sine x plus 3, let's say. This is y is equal to 2 sine x plus 3. So see how I will be drawing this, okay? So first of all, I have these vertical and the horizontal axis. You see, I'm not using the calculator at all. So I have to mark this after every 90 degrees. This is 180, this one is 270, and this one is 360 degrees, okay? And now I will be showing the axis, okay? After the marking the horizontal and vertical axis, I have to show the axis of the curve here, okay? So let me draw that. Like this is going to be 1, 2, 3, 4, 5, okay? So we have the axis at 3. So I'll have a dotted line for this. You have to use the rulers for this. Remember, you will not be given the graph papers or anything in your P1, P3, and P4. The graph paper is only used in your statistics paper, okay? This is 1 and this is 5. Now, this is the axis over here. So you have to show this axis through a dotted horizontal line. And then you see that what is the amplitude, okay? So the amplitude is 2. So 3 plus 2 is going to be 5 and 3 minus 2 is going to be 1. So this is the maximum and this is the minimum, okay? Now, for some of you who are just weak-minded like me, for these people, I would suggest them to remember these values like 0, 1, 0, and -1, okay? You have this, and then you can have this over here, okay? And then you talk to yourself, you say, okay, when sine x is 0, because this value is changing. When sine x is 0, you see, uh, 2 into 0 plus 3, what do you get? You get 3. So that means you will have 3 here and you have 3 here, okay? When your sine x is 1, so that would be 2 into 1 plus 3. So that is going to be 5. So you have 5 here. And when your sine x is minus 1, so this is 2 into minus 1 plus 3. So that is going to be 1. So you have 1 over here. For the smarter ones, for the tez bachas, just remember that you show this axis over here, okay? And then you remember this is the amplitude over here. So 3 plus 2 will give you the maximum value, and 3 minus 2 will give you the minimum value. And then you draw this curve. Remember, sine is going to be, the flow is going to be x is maximum, x's minimum, and the x's, okay? So here is the sketch for this beautiful graph of y is equal to sine x plus 3. So this is going to be like this. That is your graph of y is equal to 2 sine x plus 3. Okay. And suppose if you have to draw the graph of y is equal to, let's say you have 3 minus 2 cos x. Okay. This is 3 minus 2 cos x. No problem. Okay. We have the vertical and the horizontal axis. So this is 0, 90, 180. I'm telling you, you have to use the rulers, okay? I'm just drawing this roughly, but you people have to use the rulers. And if you have like using the ruler, if you mark the scale, so you will have a perfect curve here, okay? So this is 1, 2, 3, 4, 5, okay? And this is your 1, this is your 3, this is your 5, okay? So we have the x's at this 3, okay? Now the cos x is a minus coefficient. So that means the flow of this curve is going to revert. So instead of starting from the maximum, this is going to start from the minimum. So this is going to be minimum x's, maximum x's, and this is your minimum value, okay? So this curve is going to be like this. So this is the graph for y is equal to 3 minus 2 cos x. Okay? And you can try these graphs. I'll be giving the last version of this graph in the next video, next segment. That is, now please try these graphs. Y is equal to 2 sine x minus 1, and you have to draw all of them from 0 to 360, okay? And y is equal to 3 cos x minus 2. Just note them down, and then you try their plots, okay? Then you have y is equal to let's say 2 cos x plus 3, y is equal to 4 sine x minus 5, okay? Noor is asking that do we only have to show the axis of the curve, or do we have to show all the x-axis and the y-axis? Yeah, that is what Noor you are asking, I think, Hannah. So guys, you have to show the original axis and then you show this axis of the curve, okay? There is a difference in the axis of the curve and then the horizontal and the vertical axis here, okay? So please remember, you have to show this all the scale, you have to show the scale vertical axis, the scale horizontal axis, and then like this, your curve should be like this, the way I have drawn it here. Just one thing, like sometimes you have to draw the graph in the radians. It is not sometimes, it is half the times you must be knowing how to draw the graph in radians. So you know that in radians, your 90 is pi by 2, okay? So you look at this is pi by 2, then 2 pi by 2 is pi, then this is going to be 3 pi by 2, and then this is going to be 4 pi by 2. So which is going to be 2 pi. Suppose I'm drawing this graph for this y is equal to 4 sine x minus 5, okay? So if I have, now there is no need to take the minus 5 very down over here. I can simply have minus 5, like, this is 1, 2, 3, 4, 5. So this is my minus 5 here, okay? And this is 1, 2, 3, 4. This is minus 9, and this one is minus 1 here, okay? So because its maximum value will be at minus 1. So just showing you how to do this in case of radians. So this dotted line is the axis of our curve, and now this is going to be, and here, like, sine starts from the axis, maximum, axis, minimum, and this one is the axis here, okay? So we can draw it like this. This is the graph for y is equal to this one graph I have drawn here and taken the angles in radians. Okay, guys, so that's it from this session. Let's move on to the next session where I'll tell you how to draw a full-fledged like graph like this. Y is equal to a sine bx plus c. So far, you have seen that this a is the amplitude, okay? And this C is the axis. And what do we mean by this B? So that we shall do in the next segment. Okay. Thank you very much. Let's enter the next section session.